What is the difference between multi-component and pure substance phase changes? Imagine you're watching a pot of water boil or ice melt. These simple changes seem straightforward, but when you look closer, things get pretty interesting. Today, we're going to explore what makes phase changes in pure substances different from those in multi-component systems. This is a key part of understanding thermodynamics and how materials behave under different conditions. A pure substance is made of only one chemical component. Think of pure water, which is just H2O molecules. When it heats up, it melts at exactly 0 degrees Celsius or boils at 100 degrees Celsius at standard atmospheric pressure. These phase changes happen at specific temperatures and pressures, which are fixed for that substance. The phase diagram for a pure substance shows clear lines where solid, liquid, and vapor phases meet. These lines are called phase boundaries. At the triple point, all three phases can coexist at a unique temperature and pressure. Because there's only one component involved, the transition from one phase to another is sharp and well-defined. Now, when we talk about multi-component systems, things get more complicated. These systems include two or more different substances mixed together, like an alloy or a refrigerant blend. Each component has its own properties and phase behavior. Instead of changing phases at one specific temperature or pressure, the components can do so over a range of conditions. For example, in a mixture of water and alcohol, the alcohol might evaporate at a different rate than the water. The phase diagram for these systems is more complex, showing regions where multiple phases coexist with different compositions. The Gibbs phase rule helps us understand this complexity by relating the number of components, phases, and degrees of freedom. It tells us that in multi-component systems, the number of variables we can change increases, making the phase changes less straightforward. In practical engineering, knowing the difference is vital. When designing cooling systems, fuel mixtures, or metal alloys, engineers need to understand how each component behaves during phase changes. Pure substances are easier to model because their phase changes happen at fixed points, but real-world materials are often multi-component. These systems requiring careful analysis of how the different parts interact and change together. To sum up, pure substance phase changes happen sharply at specific temperatures and pressures, with clear boundaries between phases. Multi-component phase changes happen over a range of conditions, with phases that can have varying compositions. This difference influences how we model, design, and control many engineering processes involving heat transfer and material behavior. Understanding these principles helps us work more effectively with real materials and complex systems.